I'm Koneru Siddhartha. I'm studying in Weltech Multitech Dr. Rangarajan Sakunthala Engineering College, and I'm doing my Bachelor's of Engineering in Electronics and Communication Engineering Department. My project is with machine learning based suspicious activity detection for the surveillance application, and it is guided by Mr. A. Mohamed Abbas M.E, and my teammates are Guru Satya Dattatreya and colleague Srinivas Reddy. Let's dive into your project. Abstract. Nowadays, the suspicious human activity recognition is one of the most important applications in the human activity tracking, which is done using deep learning methods. So this proposed work involves in the development of a completely automated security system that detects anomaly behaviors in real time and report immediate alerts to the respected departments or to the concerned authorities. Now, in this system, we use machine learning techniques to analyze and detect suspicious human behavior in real time using the CCTV data and generates an alarm if an abnormal activity is detected. Now, the main objective of our project is to develop a surveillance system that can detect suspicious activities and report to concerned departments. To do this, we are implementing a slow fast network model to detect the suspicious activity. Existing system. Uh, the existing system in earlier days, we used to do the surveillance with the help of a person sitting in front of a monitor with a large consumption of time and with a large amount of labor. If at all a crime is committed, then the concerned authorities are informed after the crime is done, and when the police department come to check the security footage, which is also a waste of time. Later on, some models are developed using machine learning and deep learning models to recognize the action a person is doing. Now, there are a lot of people who worked on this project, that is Jewel Ren Asset Lucy. He done his project under the title Deep Convolution Neural Network for image deconvolution. In this, movies are used to study everyday human activities like walking, running, caring, helping, using CNN and RNN. In 2017, Nishani E and Siko B done their project under the title Deep Neural Networks for video analysis of human pose estimation. In that, they develop a real-time system for detection of aggressive and violent conduct using CNN and RNN. In the next years, there are also a lot of people who have done project on this under many various titles. So all they've done is almost the same, but only with a few developments. Now, in what we have learned is that in the training data we collected from the movies and sports footages instead of original CCTV footage. That means like they didn't take the or they didn't capture the videos in real time. All they've done is took a footage from already a certain database or they've took footage from movies. Earlier, the classification is done purely on based on actions of individuals. Later, the spatio-temporal analysis came into action for better detection of the results. Proposed work. In our proposed work, we are developing a suspicious activity detection model based on slow fast network, which is state-of-art model. Training the model with CCTV footages instead of normal training databases. Implementing spatio-temporal analysis strictly. Now, all of this is based on CNN. CNN is known as convolution neural network. This is a type of neural network that is used to analyze input using specified grid-like architecture. A digital image is a binary representation of visual data, as we all know that. It also contains a series of pixels arranged in a grid-like fashion. This grid contains pixel values to denote how bright and what and which color each pixel should be. A CNN typically have three layers: a convolutional layer, a pooling layer, a fully connected layer. Next, Slow-fast network. Slow-fast network is an open source video understanding code base from FAR, that is Facebook AI Research. It provides state-of-art video classification models with efficient training. It provides the high performance, lightweight, code base backbones for video understanding. It also works on different tasks like classification and detection and etc. In short form, a slow fast network has a slow frame rate, low temporal resolution, slow pathway, and high frame rate. In slow fast model, we'll be operating at a low frame rate to capture spatial semantics, and a fast pathway operating at the high frame rate to capture motion at fine temporal resolution. Now, it is designed in order to support rapid implementation and evaluation of novel video with research ideas. The slow-fast network includes implementation of the following backbone network architectures: slow-fast network, slow C2D, I3D, non-local network, X3D. We previously talked about the CNN, the convolutional neural network. It is based on its convolutional layers. Since, as we've talked, there are several different layers in CNN. The convolutional layer is one layer of it. In convolutional layer, it performs a dot product between two matrices. The convolutional layer is the core building block of the CNN. One matrix is set of learnable parameters, otherwise known as the kernel, and the other matrix is restricted portion of the respective field. The kernel is spatially smaller than an image but is more in depth. If the image is composed of three channels, the kernel height width will be spatially small, but the depth extends up to all three channels. This is the illustration of convolutional operation. The other layer of CNN is pooling layer. It replaces the output of the network at certain locations by deriving a summary statistic of the nearby objects. It helps in reducing the spatial size of the representation or the image that we are processing, and thereby decreases the required amount of computation and weight, which helps us to make the process a little bit faster. In the pooling layer, the pooling operation is processed on every slice of the representation individually. In pooling operation, we have max pooling, in which the pooling selects the maximum element from the region of the feature map covered by the filter, and it's fully connected. The neurons in this layer have fully connectivity with all neurons in the preceding and succeeding layer, as seen in the lecture FC and N. This is why it can be computed as usual by a matrix multiplication followed by a bias effect. The fully connected layer helps to map the representation between the input and the output. So this is how we get an output using the slow fast network, which is in action. Now let's see the block diagram. This block diagram is very simple. We'll be taking the video signal as the input, which is collected from the CCTV. Then the video is extracted into frames using OpenCV. Then each image is converted into the resolution of 224 into 224 matrix, which such that it will be easy and faster to do our process. Now the image is trained using slow fast network, which is based on a 3D CNN. If it finds any abnormal activity, or if it finds if the activity which is being done is suspicious, then it will send an alarm to its concerned authorities. If it isn't normal, then it will proceed to the next part. Like it will go to the next video. Now let's see the implementation. At first, we will be collecting the input in the format of video recorded through the spy camera, or in real time we'll be collecting the video with the CCTV. Since we cannot process the entire video, it needs to be converted into frames, and we will be converting it with the help of OpenCV. As different frames are at different sizes, to maintain a uniformity, we will be changing the frame size into 224 into 224 pixels, which is height into width, or the height into breadth. Now, this is the important task to train a machine learning model, wherein the model will understand the features of the image with the help of NumPy array. We will be using the stochastic gradient descent optimizer class in Keras for implementing learning rate and momentum. It is an iterative method for optimizing an objective function which with suitable smoothness properties. Now, the slow fast network is state of art network, as we have spoke about it. It is used for action recognition. It has two pathways, slow pathway and fast pathway. In slow pathway, it operates at low frame rates and extracts spatial features. And at the fast pathway, it operates at high frame rates and extracts the temporal features. The pathways are combined to predict in action such that we will be having better accuracy and we'll be having better results. And such that our process is faster. If the action is said to be normal, then it continues to the next set of frames. And if the action is said to be suspicious, then it will send an alarm to these concerned authorities. As we have is shown before, this is how our output is being showed.
We have done all our project in Anaconda platform. So first we have to activate the Anaconda prompt for running all our commands. Now I have opened our Anaconda prompt. In our Anaconda prompt, first we have to list all the environments which are present in there, because many people can be using it and they will be creating their own environments. First we have to get to know what are the environments. So if we env list, that is running it, and it's showing us there are two environments. One is base environment and is fourth year project. Fourth year base environment is default one. Fourth year project is what we have created for our project. So we have to activate it. To activate the environment which we have created, that is conda activate, and what we have created, fourth year underscore project. Let's copy it and paste it here. Now it's got activated. Now we have to open the folder in which our model is there. Our model is there in this activity move nodal thing. So let's copy the format, and all our code is there in this one, app.py. Here we have used the Flask framework. Under the Flask framework, our port is port 8000, and it is hosting in our local host. So let's paste it here. We have pasted our project folder path, and now it's activated. So now we have to activate the Python code which we have written. That is Python. The folder name is app.py. Okay, it started running. Meanwhile, it got executed. Let's open the Google Chrome and go for our local host and in the port 8000. Let's wait for our Flask environment to get activated. Yeah, I think it's done. Yeah, our camera is blinking, so it's done. Just refresh it once. Yeah, you can see our camera module is is there, and it's getting for the footage, and I'm showing a footage of a robbery. It's happening in a yeah, it's figured it out as robbery, and we can get the same thing through our mail also as an alert. Here if you see it, I'm just refreshing once again. Yeah, when I refresh it, it sent me an alert stating that there is a alert and it's a robbery, and that's what our
Now, there are a lot of advantages using our project. It will be the less time consumption since it will all of the activities are done automatically using the highly advanced machines. We will also, since we are using advanced machinery, we'll be having better accuracy, and there is no need for any person to stand by near the monitor, since we'll be getting automatic alert if and suspicious activity is detected, and it is also cost efficient since we don't have the need to pay the labor to manually uh, do the work. There are a lot of applications for this, like we can use it in airports, bus stand, and auto stands, in public places, banks, parking spots, and abandoned places. In that, we can look for any bombs if someone is planting, if there is any theft going on, if there is any robbery that is going on. Conclusion and future scope. There are numerous possibilities, and this can be explored further. Although everyone in today's world understands the importance of CCTV, it is rarely used in aid in the inquiry of a crime or event. The proposed solution has the added benefit of stopping crime before it even starts, if possible. In real time, CCTV footage is being tracked and analyzed such that a system that analyzes in real time, reducing the need of human involvement. In the future scope for better optimization and for better processing, we suggest doing the model using tiny machine learning and better optimization techniques, so it can be implemented in devices with less processing power like traditional microcontrollers, and development of boards like Arduino and Raspberry Pi. These are the papers that we have referred in the making of this project. Okay, thank you guys.